Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Clustering is an unsupervised machine learning technique used to group similar data points together without predefined labels. The algorithm identifies patterns and similarities within the data and creates groups called clusters. Unlike classification, clustering does not require the correct category to be provided during training. Clustering is commonly used for customer segmentation, pattern discovery, document grouping, anomaly exploration, and exploratory data analysis. Clustering algorithms analyze the characteristics of data points and measure how similar or different they are from one another. Data points with similar characteristics are grouped into the same cluster, while dissimilar points are placed into different clusters. The algorithm uses a similarity or distance measure to determine relationships between observations. The resulting clusters can help analysts understand hidden structures and patterns that were not explicitly defined in the data. Classification is a supervised learning technique that uses labeled training data, while clustering is an unsupervised learning technique that works without predefined labels. Classification predicts a known category, while clustering discovers groups that may not have been identified beforehand. For example, classification can determine whether an email is spam, while clustering can group similar emails based on their characteristics. Choosing between them depends on whether known target labels. K-means is one of the most common clustering algorithms and groups data into a specified number of clusters. The value of K represents the number of clusters that the algorithm is expected to create. The algorithm assigns data points to clusters based on their distance from cluster centers called centroids. K-means repeatedly updates the centroids and assignments until the clusters become stable or a stopping condition is reached. Selecting an appropriate number of clusters is an important part of using K-means effectively. The elbow method compares clustering performance across different values of K to identify a point where additional clusters provide diminishing improvement. Other evaluation approaches such as silhouette analysis can help assess how well observations fit within their assigned clusters. The best number of clusters should also make sense from a business or application perspective. Clustering algorithms often rely on distance or similarity measures to determine how closely related data points are. Euclidean distance is commonly used in K-means to measure the distance between observations and cluster centroids. Features with very different scales can influence distance calculations disproportionately, which can affect the resulting clusters. Feature scaling or normalization can therefore be important when numerical variables have significantly different ranges. Because clustering does not normally use predefined labels, evaluating the quality of clusters requires different approaches from supervised learning. Measures such as silhouette score can help determine how well data points fit within their own clusters compared with other clusters. A good clustering solution generally has groups that are internally similar and sufficiently different from other groups. Evaluation should also consider whether the discovered clusters are meaningful, stable. Businesses can use clustering to group customers based on purchasing behavior, engagement, preferences, or other characteristics. Organizations can group documents, products, images, or other content based on similarities within the data. Clustering can help identify unusual groups or patterns that may require additional investigation. It can also support recommendation systems, market analysis, exploratory research, and data-driven decision-making. Clustering results can depend heavily on the selected algorithm, distance measure, feature representation, and number of clusters. Outliers and noisy data can influence cluster formation and may lead to misleading groupings. Some algorithms work better for particular shapes, densities, or types of data than others. Clustering results should therefore be interpreted carefully and validated using both statistical measures and domain knowledge. Azure Machine Learning can be used to develop and manage machine learning solutions that include clustering and other unsupervised learning tasks. Developers can prepare datasets, select suitable algorithms, train models, evaluate results, and deploy solutions using Azure Machine Learning capabilities. Automated machine learning and other Azure tools can help simplify parts of the model development and experimentation process depending on the scenario. Clustering is an unsupervised machine learning technique that discovers groups of similar data points without predefined labels. K-means is a common clustering algorithm that uses centroids and distance measurements to create a specified number of clusters. Techniques such as the elbow method and silhouette analysis can help evaluate and select an appropriate clustering solution. Understanding clustering, its differences from classification, and its real-world applications is an important concept. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoomin Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.